Hello, welcome to the first video. We are going to be talking about lesson 3.2.4 today. And before we start this lesson, you are going to need to make sure you have a couple things with you. You need to find your 322 handout because on the back of that handout, there is this table. And we're going to be using this table today, so make sure you have that. The other thing is make sure you have a calculator because we're going to need that calculator as well. Okay, so if we get started on 3.2.4, we have been talking about tangent ratio. We have that table that we've been using for the tangent ratio, and we are going to continue to work with that table and find out what tangent is. Even though we haven't called it tangent, we have been doing it. I'm going to start on this problem 100A. So notice that we have a 79-degree angle and we have a 90-degree angle. So this is where your calculator comes in. Can you use your calculator to find out if this is 79 and this is 90, what is the leftover that's left over for theta? Remember that symbol? That means theta, and that just stands for an angle. Go ahead and do that on your calculator and see what you get. Okay, you should have gotten 11 degrees. So when we look at this in this triangle, we can look at it in terms of the 11-degree side, or we can look at it in terms of the 79-degree side. I'm just going to work with the 11-degree because that's kind of what we had started working with when we very first started this solving. So now I'm going to go to my table, and I'm going to look for an 11-degree, and I'm going to find out what the slope is on an 11-degree angle. So I'm going to go back to my table, and I have 11 degrees, and here on my table it tells me that 11 degrees has a slope of 1/5. So I'm going to go back here where I was on my paper, and I'm going to say that an 11-degree slope is 1/5. The next thing I'm going to do is I'm going to set up a proportion, and I'm going to say that 1/5, and again, I'm looking at it in terms of this 11-degree. And so my rise is W and my run is 12. So I'm going to say W/12 because that's rise over run for the 11-degree. And now I'm just going to solve it. To solve it, I'm going to cross multiply. So I'm going to multiply 5 times W and set that equal to 1 times 12. And I know that 1 times 12 is 12. And now I just have to finish it out by working out the math. And again, I go to my calculator and I take 12 divided by 5. And 12 divided by 5 on my calculator is 2.4. So now the problem had asked me to find theta, which I did. Theta is 11 degrees. And it had asked me to find W. And W is 2.4. Let's go to the next problem. All right, similar deal. We have a 22-degree angle. We have a 90-degree angle. I'm going to use my calculator, and I'm going to take 180 for a triangle, minus 90, minus 22, and I'm going to see what I get when I do that. So 180 minus 90 minus 22 is 68 degrees. So my theta here is 68 degrees. And once again, I can look at this triangle in terms of the 68 or in terms of the 22. Doesn't really matter. Since it's kind of set up where the like the 68 is kind of here on the bottom, I kind of think I'll do that. I'm hoping I have that on my table here in just a second. But I'm going to find for the 68 degrees, I'm going to go back to my table and I'm going to try to find the slope for a 68-degree angle. So I'm going to go back to my table, which is here. Come on. Nope, doesn't want to go. Okay, good, I do. 68 degrees is 5/2, or 2.5. I could really do either one. I'm going to stick with 5/2. All right, so 68 degrees, the slope is 5/2. So I'm going to set up my proportion. And I'm going to say 5/2 is rise over run. And so if I look at my triangle from the position of the 68 degrees, my rise is 8, my run is z. So I'm going to say 8 over z. And once again, I'm just going to cross multiply and solve it from there. So 5 times z is equal to 2 times 8. Well, I know 2 times 8 is 16. And now I just want to solve it. And so I get z equals, go to my calculator, 16 divided by 5. 16 divided by 5 is 3.2. So once again, I have now solved and answered the question. I have found theta is 68, and I found z is 3.2. Let's try one more of those. Okay, we have our 180-degree triangle. We have a 90 and an 18. So 180 minus 90 minus 18. When we do that, we get theta equals 62 degrees. So once again, I can look at this in terms of my 62 or in terms of my 18. Sometimes it helps to sort of rotate the triangle around to because right now it's sitting on the hypotenuse, and sometimes that's confusing. We want to kind of make it sit up straight. So if I did that, I could do it either way. I think I'm going to do it, I'm going to spin it around so that it's more like this. And so this was my 62 degrees. This was my 18 degrees. My 15 was here and my x was there. I just did that to kind of help me see what's going on. So now I can look at it in terms of my 18 and go rise over run for that. I think that's what I'm going to do. So I have the 18-degree angle, and I need to go back and look at my paper and find the slope of that. Give me just a second. So let's see, we have this table. I don't know why it's not letting me do that. And we are looking for 18 degrees. 18 degrees looks like it is a 1/3 slope. So I'm going to go back to my paper. And I have a slope of 1/3. So I'm going to set up my proportion. And my proportion is 1/3. That's rise over run. And this triangle that I'm looking at has a rise of x and a run of 15. So I'm going to go back and I'm going to say x over 15. And once again, I'm just going to cross multiply to solve this. So when I cross multiply, I'm going to take 1 times 15 and 3 times x. So 1 times 15 I know is 15. 3 times x is just 3x. I'm going to solve that, and I get my final answer. 15 divided by 3 is 5. Okay, so once again, I have the two things that I need. I have the theta is 62 degrees, and I have that x is 5. All right, that is the basics of trying to set up a proportion and find it using this rise over run, these slope triangles that we've been using. I'm going to skip number 101, and I'm going to go to 102. Okay, here is the big reveal here, is that for this, we can use a scientific calculator, and we're going to learn how to do that today. So it says, examine the triangle at the right. According to the triangle at the right, what is the slope ratio for 32 degrees? Okay, if I look at my 32, my slope ratio for 32, slope 32 degrees is rise over run. And my rise for this 32 is 5, and my run is 8. It says, explain how you decide to set the ratio. We did rise over run. Write the ratio in both fraction and decimal form. Okay, I'm going to write it down here. I'm going to say slope of 32 degrees is 5 over 8. I'm going to go to my calculator. I'm going to put that into my calculator, and I'm going to get the decimal for 5 over 8. And as it turns out, 5 over 8 is 0.625. Okay, we are done with question A. question B. I'm going to erase this. Oh gosh. Question B says, what is the slope ratio for the 58-degree angle, and how do you know? All right, now I'm looking at the 58-degree angle, which is here, and the slope for this one, the rise is 8 and the run is 5. So this time I'm going to write down the slope of 58 degrees is a rise of 8 and a run of 5. I would actually go back. I skipped number 101, but there's an important question that we actually need to kind of look at for on 101. I don't think we need to look at the whole thing, but question B gets to what we have been kind of alluding to. I have been, I guess. So the idea is they're looking at this triangle. They have the 18-degree angle here. This other student says, what if we use 72 instead? What would happen then? And so then the question was, how would you, whether you're using the 8 or whether you're using the 72, how would you know which one to put on top? And so basically, I want to take just a second to talk about rise over run. And the rise is the number across from the angle. Write that down. And the run is the number, I'm going to say attached. That's not the greatest word, but attached to the angle. And so we're still talking about rise over run, but we're looking at which one's across and which one's attached. So back to these students up here in the corner, the 18 would be, the rise would be 4 because it's across, and the run would be A because it's attached. I think I'm going to write that down. I think you should too. So let's say if we're talking about 18 degrees rise over run, then the rise is the 4 and the run is the A. But if we look at the other one, the 72 degrees, in that case, when we look at rise over run, we're looking at A, because that's across, and 4, because that's attached. Okay, I wanted to make sure we have that distinction. Now let's go back to where we were. We were on 102C, and they're saying that there's a button on our calculator. Scientific calculators have a button that will give us a slope ratio when the angle is entered. In part A, you calculated the slope ratio for 32 degrees as 0.625. Use the tan button, that's tangent, on your calculator to verify that you get approximately 0.625 when you enter 32 degrees. Let's go to our calculator and give that a try. So here we have our calculator. We have these buttons here. I don't think I have a pointer with this calculator. So we have the buttons here next to the divide symbol is the tangent. And then we're going to put in, what were we working with? We were working with 0.625. 0.625. And we hit enter. That wasn't what we were looking for, was it? Oh, 32 degrees, sorry. Let's clear that out. Okay, sorry. Tangent of 32 is, why do I have 0.66? I think it's supposed to be 0.625. Tangent of 32.66. Oh, I'm back in radians again. Okay, I don't know if you can see it, but there's up in the upper right-hand corner, I had changed it earlier to degrees, and it changed. So if you're getting the wrong answer also, we want to go into mode. We want to go into degree. Enter. Let's clear this off. Clear. Let's try one more time. Tangent of 32 is 0.625. That's what I was hoping for. Okay. And then it says, does that button give you approximately 1.6 when you enter 58? So let's try tangent of 58 equals 1.6. Okay, that tangent button is what we are going to be using a lot of. So make sure you understand where it is. It's next to the division symbol. and then you just type in. If you're getting the wrong answers, check on the very top of your calculator. Make sure it has a degree, not a rad in there, okay? Let me go back to the paper. Okay, so we did that. The ratio that you've been studying in a right triangle is referred to as the tangent ratio. When you want to determine the slope ratio of an angle, such as 32, it is written tan 32 degrees. So an equation for this triangle can be written as tangent of 32 equals 5/8. Write an equation for the right triangle using tangent of 58 degrees. Okay, so what they're talking about is the top of this page. We are going to write down, and we are going to say tangent of 58 degrees. And now if we look at that 58, the tangent is rise over run, so that's 8/5. So 8/5. That is really just another way to say what we were saying all along. It's just we actually have a button on our calculator, so we don't have to keep going back to that table. We can use our calculator, and it does it for us, so we don't have to keep using the table. Okay, let's take a look. This is going to be the last one that we do together here in this video. It's a lot like the beginning problems, but now we are using our tangent button instead of using the proportions. So it says copy each triangle. You don't have to, you have it. Label its legs, delta y and delta x given. Okay, then write an equation. Okay, so instead of using delta y, delta x, I'm going to say rise. This is my rise, and this is my run. And it might look backwards to you. You might be thinking, why is that the rise and run? It seems backwards. Well, because if this is my 38, then this is the rise compared to the 38. Like I could draw it sideways, right? I could make my triangle like this, and then the 8 is my rise, and the x is my rise, and the 8 is my run. Let me actually draw that because I feel like that's kind of confusing to you. So let me say, if I twisted this triangle around and drew it like this, then I would have my 38 over here, my x is over here, my 8 is down here. So now, if I say the tangent of 38 degrees, it should be rise over run. That's x over 8, okay? Now, I'm going to erase that triangle so I have some more space. Now, we're going to go to our calculator, and we're going to type in the tangent of 38. So we go tangent 38 equals 0.78. So I'm going to go back to my paper, and I'm going to rewrite this. And I'm going to say, I'm running out of space. Let me help myself move this over here a little bit. Okay, so I have tangent of 38 equals x over 8. I just found on my calculator that the tangent of 8, why do I have 8? Oh, sorry, tangent of 38 is 0.78. So I'm going to change this. Instead of saying tangent of 38, I'm going to say 0.78. All I did was I changed that tangent to 0.78. Next, I'm going to cross multiply. When you have a decimal, we can always put it over 1, okay? So now when we cross multiply, we're going to multiply x times 1 and 8 times 0.78. So when I multiply x times 1, that's easy, that's x. I'm going to go to my calculator, and I'm going to take 8 times 0.78, and 8 times 0.78 is 6.25. Okay, so once again, we have the x that they were looking for. It says label the legs, then write an equation and solve for x. So we did. We solved for x. Let's try another problem. Okay, once again, I could redraw this. If I wanted to make it a little bit more clear, I could redraw it. And this one up here is my 73. And this down here is my 9, and this is my x. So, if I wanted to use the tangent of 73, Then I'm going to write down tangent of 73 is rise over run. If I look at this 73, my rise is x, my run is 9. So I'm going to say is x over 9 for rise over run. Then I'm going to go to my calculator. I'm going to find the tangent of 73. Tangent 73 equals 3.27. So I'm going to write that down on my paper. 3.27 is equal to x over 9. Once again, if I have a decimal, I can put it over 1. If I put it over 1, now I can cross multiply it. Okay, so when I cross multiply, I get x equals, and 3.27 times 9 on my calculator. Why do I have 12? Oh, again, I'm looking at the wrong one. 9. Okay, 3.27 times 9 is 2.75. That's not right.